So you have all done the assignment, right? The reason I go through this is just because this is the newest one, and I think it's good to review this one. And in this process, I will go through some of the basics that you are supposed to know, right? So the first question is this. It's a little bit complicated. This first question is saying that for this circuit, right, we don't care about what the other working circuit is, right? But for this circuit, what are the poles, right, of the circuit? It's complicated but straightforward actually, right? So how many capacitors do we have? 12 capacitor, thank you, right? Because we have three transistor, right? So do it mechanically, right? Do not get it wrong, right? This is CGS1. So difficult to write. And then you have CGD1, CSB1, right? And then you have CDB1. Is that okay? Then to speed up, I'm going to combine them. What else do I have for this one? For the M2, I have CSB1, right? So CSB1, they all connect to the same place. So I just add CSB1. And here, what is this? CDB2, right? And how about this one? The gate and the drain? CGD2, but can I combine with CDB2? Because this is grounded, right? All the constant current source, right? I mean, yeah, constant voltage source, right? CDG2, okay? And then I still have one more, which is between the gate and the source. So what is that? I can combine with this one, CGS2. So obviously this is wrong also, but no one point me out. This is not CSB2. What is that? How do I erase? SB2. Right. Again, I said this is a tutorial. Let's just get this done. Everything correct. Please, everyone participate. Then you don't need to go back to study this again, right? So I count this. I have 8 capacitors already, right? And then I need to do this one. What is this one? Okay, but what do you call it? CGD3, right? And then how about from B2 to here? How do I do that? How about this one? I am going to group it together, right? What's the good way to point? Oh, I know what. Yeah. So I'm talking about this one to here. What is this? CGS3. But CGS3 is, again, I can combine with what? I can combine with this one, CGS3. Make sense? Anyone cannot see it? I'm combine this CGS3, this one, and become this one, CGS3. Do you agree? Yeah. Because they have the both terminal, one of them connected to ground, one of them connected to this node, right? Okay. So I still missing 2 more. One is C, D, B, free, and then C, S, B, free. But again, this one I can do what? Combine with this one, right? C, S, B, free, because the B is grounded, right? And then now we do the simplification. This one is gone. Ground, ground. This one is gone, right? And what else? This one is gone. Yeah? So from here, I am almost done, right? I have 3 nodes. If I look at this carefully. 1 capacitor, 2, and 3. 3 group. But then I have the CGD1. How should I treat it? Parallel plus CGD1 times what? Actually, what do you mean by parallel? Huh? 1 minus A. Yeah? And then what else? Do I just stop here for 1 minus A when I split it? You need to go to the output port. 1 plus A times CGD1. Yeah. Now you are good. I'm just tricking you. I'm just testing you. CGD1, very good, right? Now, so let's check if I do it right. Let me make it smaller. Right, so I have 3 poles. One is CDB2 plus CDG2. C here, CDB2 plus CGD2. I have one that is CGS1 times CGS1 plus CGD1 times 1 minus A, CGS1 plus CGD1 times 1 minus A, and then one of them has 1, 2, 3, 4, 5, 6 term. I did not check it. 1, 2, 3, 4, 5, 6 term, including the, right? So I assume I'm correct, right? Then the rest is to find the resistor, right? The first thing. How do you find the resistor? Let's look at the first pole. What is the first pole resistor for this one? This is what I mean, the first pole. Yeah, you ground V in and then RG, right? So the pole is 1 over RG times this whole thing. Here, I have another pole, right? What is the resistance that can bring me to ground? RO of what? RO1 when I look down, and then 1 over GM3 looking up, and say again, 1 over GM2, right? And I believe I say no channel length modulation, so I can ignore this guy, right? So it'll be GM3 plus 1 over GM3 plus GM2, right? Wait, that I had problem before. It's, right, GM2 plus GM3, right? Do you see this? Because its gain is 1 over GM2 parallel 1 over GM3 is the same as 1 over GM2 plus GM3. Because it's conductance, you add them together and then you find the effective resistance, right? And then this is 1 over GM2 plus GM3. And that's why we get this one. Okay, good. Then how about the output? What is the pole? What is the resistance? Say again? Huh? Why 1 over RD? What is the resistance? Oh, I see what you mean. I'm asking the resistance, so it's just RD. Yeah, but when you plug in, it's 1 over RD divided by C. Okay. Okay. Yeah, so that's okay. That's what. That's your LD. How about the one thing looking down? What's that? No channel length modulation. If there's channel length modulation, what will you do? Parallel R2 only? With degeneration. What is the, yeah, then you can check the equation, right? But what is the degeneration resistance here? Approximately. R1 parallel 1 over GM2. Right? You need to look at that. That is correct. Right? Because when I look down, this is 1 over RO2, RO1, and this is 1 over GM2, right? Yeah, but no channel length feature. Okay, so we're done, right? But what is A? How do you find the gain of this? So everyone can follow? I mean, if your question, just ask now. Do not think that those are answering me. Actually, I pay them. That's they try to try to make, pretend that they know, right? Please, let's discuss really. Because if you ask a question, you're actually helping everyone. Is this clear? How to find the capacitor, how the resistor? I can tell you the final exam is easier than this one. But if you don't understand, you will mess up still. But if you can understand this one, the one in the final exam is super easy. But I'm sure still many of you will make mistake. Is that clear? Okay, how about A? How do you find the A? The gain. The gain, not for the, when I say A, I'm talking about this A, right? The gain for the Mueller cap. That's what I'm asking for. Okay, so let's call this X. It is X divided by V in, right? What is the gain? Huh? Current source? Common source. Sorry, my ear. Common source amplifier. Exactly. What is the gain for common source? Negative what? 1 times RO1 parallel 1 over GM2. And since I say there's no channel length modulation, so I ignore RO1, right? Oh, GM2, GM3. Okay.
For this problem, let's assume GM1 equals GM2 equals GM3.
Then what would that be?
I think it's 1 over GM squared. Oh, no. They're in parallel.
Yeah, they're in parallel.
I'm sorry, unable to do math right now.
What is GM divided by 2GM? 1/2. Very good. So this is what we have, right? As I said. Okay, so I'm right. So you're done, right? I just hope you, at this stage, hope all of you guys are very good already, understand a lot, right? Particularly you're able to do the homework. I know many of you actually do it by yourself or together, we really understand, except maybe some of you just copy, right? So you know everything. The only thing you need to do is to slow down, not just for the exam, in the future. Think carefully. Just keep telling yourself, I always make mistakes. Let me be careful, step by step. That was my problem also when I was a student. And that made a big difference. I can tell you, I went for an interview, like consulting firm where I graduated, right? I was so happy. They give me the first, after phone interview, they give me an interview. And then they gave me a table, very simple table. Even elementary school student can tell, like, what is the total number of product they sold or whatever. But I don't know why, I just did the math wrong. I read the table completely wrong. And of course, I got rejected, right? I think I did very well after that, because they have many interviews, many questions, right? The first one is just a stupid and super easy one. They just want to test your aptitude. I mean, if you can make this type of stupid mistake, they cannot rely on you for the future, right? Even you know all the math. So remember to tell yourself, I always make mistake. Be careful, even it is simple. That make a big difference in your life. Trust me. I always do things twice or 3 times to get it right. Okay, good, right? So this is one of the review. Yeah. So let's maybe go forward, take a look at this one, right? Very fundamental concept. I even can tell you the input is X, the input is X, the output is Y, okay? So what type of very simple, right? You don't want to make mistake for this, right? What input and what output do we have for the X and Y based on the drawing? Is voltage or current? Voltage. In this case, you just assume it because for op-amp, we know that no current can go in, right? You really cannot take current, right? And here, if this is current, I will draw that there's some current going out because you want to take current, right? You cannot just give the note and say that this is the output. It won't be the current, right? So both them are voltage, okay? So this is the input and this is the output. Then what is the feed-forward gain? Now yeah, open loop, yes, feed forward. You don't need to give me the equation, but at least I hope you can tell me it is the gain of this part times the gain of that part. Are you able to do that? What is the feed forward gain? The gain of A1 times the circuit due to M1, right? But what circuit is that? Source follower. Exactly. Then you check your cheat sheet. I don't know if you can memorize the gain of source follower. But in the worst case, let's say you don't have this in the cheat sheet, what would you put? Source follower. 1, yeah. I should at least give you partial credit maybe for 80%, right? If not, you argue with me. Yeah? Yeah, because if you can remember it is 1, at least you know something. Although here I ask for more, is GM1, R2 is the loading divided by 1 plus GM1, R2. It should be on your cheat sheet, and we proved that before. And if R2 is very large, this is essentially 1, right? Okay. What is the feedback factor? A little bit tricky. All you need to do is just by definition, what is K? Ask yourself. Okay. Exactly. I'm glad that you said that. So it is just what I get out divided by what I put in. And V minus, of course, equal to Y, right? So this is 1. Based on this, what is the closed loop gain? You should memorize this equation, right? AO over 1 plus K AO. So what is that? All of that. You are lazier than me. Ask me to write, okay. All of that, yeah. 1 plus 1 times all of that. Okay, let's check if that's correct. Yeah, so it is like this. Yeah, yeah, exactly, right? All of that over 1 plus 1 times all of that. Is that okay? It is very simple, but if you're nervous or you don't have a concrete understanding, you can mess up. Okay? Yeah. Yeah. No, what's the definition of K? Give me the definition one more time. I mean, in this case, right? What did I say? What's the definition of K? V minus divided by Vy, right? So now he decided to put a resistor here. What is K now? And let's call this RF. There's no current. Why there's no current through RF? Because it's infinite impedance, right? Then, so V minus still equal to Vy. So it's still equal to 1. Excellent. Huh? And if you're nervous and then you think, oh, we actually learned about this 1 RF, I'm pretty sure if I put something like this, someone would say it is negative 1 over RF, because we had an example, which is the current inputs, right? And then without understanding why, then you say that. But good, huh? So you understand, right? Very good. Let's take a look at this example. I asked you to identify the sense and return mechanism. Before that, what type of circuit is it? What type of amplifier is that? Oh, very good. Transimpedance. You are saying that the input is this, right? So it's transimpedance. That is good. What type of feedback do we have for transimpedance in terms of voltage and current? VI, that is correct. Why VI?
The feedback, and on the input, which is the output of the feedback.
Very good. So he said that because this is the input of the feedback, right? And this is the output, which is I out of the feedback, right? So it's a VI. How about in shunt and series? What is this? Shunt. Shunt. Why? What is the meaning of the first shunt? No, yeah, be careful. What is the first shunt about?
Oh, that's it.
The input of the whole circuit, right? And it's current, so you need to be shunt. Because our feedback is current, we need to steal away the current, right? It's parallel connection. And then the output is also parallel, right? So here we ask, what is the sense and return mechanism? How do you sense? What do you sense? And use what method to sense? No, when we say sense and return, we need to go back to remember this one? We always say that this is sense, right? And then you have a feedback, and then this is return. So what is the sense mechanism? What are we sensing? The voltage, right? We're talking about the feedback, right? The voltage. So how do you sense it? How do you sense a voltage? Parallel, yeah. How about return? What do we return? We sense something, right? Just like the police who gave the ticket, right? So it sends voltage and return what? The current. This is very simple, this one, right? For this question. Say again? Yeah, but I'm talking about mechanism. Yeah. So when I ask you what type of circuit it is, I was trying to ask you what type of amplifier. I mean, if you look into here, right, are you able to decompose this to some amplifier? Anyone want to say something? The input is current, right? So this is a source follower, I agree, right? But is this a differential input? I'm tricking you. Is this a differential input? Again, what are the three criteria? They're not symmetrical, right? I mean, they're not criteria, but if we go back to virtual ground, we say need to be symmetrical as well as symmetrical. linearized and differential. Yeah. So this is not differential, right? Just the circuit itself is not symmetric. It's not a differential pair, right? But it look like what? So we start from here, right? If this is the input, then where's the output? Where's the output for this action? What I'm trying to say is, let's say if I ask you to find the feedback, right? Positive, negative. How will you do? You need to start from here, and then where's the output of M1? Source. So what type of amplifier this look like? Looks like source follower, right? And then from here to M2, what type of amplifier it looks like? Common gate, right? And then here, what is this? It's just told me source follower, right? This is not exactly, you cannot just plug in the equation that you have. Maybe you can actually, I think you can. But at least you need to have this understanding, right? To find out what's the feedback. Okay? So let's do one more maybe. So how about let's play with this one? This is a little bit complicated, right? So again, what type of amplifier this look like? I mean, in terms of feedback. Transimpedance, or I mean, transimpedance is the amplifier, but in terms of feedback, voltage, current, shunt, something like that. Voltage, current, right? Because the input to the feedback is voltage. Output from the feedback is current. Any question why I do the feedback this way? I mean, you should ask now instead of go back to ask people or to study. Yeah. Huh? The sense mechanism means how the feedback sends the output. Right? It sends voltage or current. If sense voltage, you use parallel. If it sends current, you use series, just like what you did on your bench. On your bench, right? Yeah.
So what you're saying is, instead of having a current parallel resistors, you'd have to have some kind of parallel divider series.
If you have a voltage input, you need to think of a way so that I can do subtraction of the voltage. I don't care how you get from the output, right? But now, for example, if I have the input, this is my input, V in. How are you going to do this subtraction from the feedback? Maybe now you can tell me since you asked that, right? I won't test this in the exam, right? But you're a circuit designer. How are you going to do subtraction based on this circuit? Yeah, let's say I already get the VF. How do you do subtraction V in minus VF or VF minus V in? Yeah, you need to connect them in series, but you cannot, right? You cannot just, because this is not really a voltage source, right? How do you utilize this circuit to do this subtraction? Do you remember? So your goal is to get some quantity, which is depends on the difference of these two voltage. Yeah, what circuit you learned that you can get a quantity which depends on the difference of two voltage? Which circuit have you learned? Differential pair is one of them. But now I only have one transistor. I am not going to waste money on differential pair. Can you do subtraction using a transistor? So that you have a quantity depends on the difference of them. Now, how about I tell you, this one can do subtraction already. Can you figure out how to connect it? Then you can do subtraction. What quantity will depends on the difference? The current of what? The drain current depends on what? Say again. Depends on VGS. Very good. And VGS is subtraction. VG minus VS. So I plug into here, right? So I'm done with this subtraction. And then now you say, how do I do the feedback? Then yeah, if you go from voltage V out to VF, then yes, then do a voltage divider, whatever you can think of. Then done. Okay. This might not be, we don't need to go to here. Okay, good. So the goal here is to, so you all know what is happening, then let's do the inspection to find out whether it's positive or negative feedback, okay? I start from here, I say this one go up, this one goes up. Then which node should I look at to see its effect? The one. So drain will go up, yeah, the one above it, you're right. Yeah, because this is common gate, is that okay? The gain of common gate is positive. I apply this I into the source. When I apply the current into the source, I increase its potential. It's just like V in increase. And then the output will increase, right? And then which node will have effect? The V out will go up. Why? It's source follower. Good. Now source follower go up, V out go up, then what happened? Which node should I look at now? Back to the input. What happened to the input then? It also go up, right? Because it's just a resistor, I pull it from another terminal, the tendency is that the other terminal will go up also. So is this positive or negative? It's positive, right? So you prove that this is positive. Okay. And then we also talk about the loop gain. How do you find the loop gain of a circuit? Do you remember? I say again. You need to find the loop, right? But basically, just now when I go through, yeah, just now I go through, you already know that this, you already show me that basically this part is the feed forward and this part is the feedback, right? So I'm going to cut the loop, but here I tell you to cut the loop at the gate of M2, maybe easier. So I cut here, okay? Then what do you do? Then you will, I will apply a test voltage, I call it VT, yeah, to here, and then I will start seeing how this works. Should I put I in here? Yeah, you open it, right? Because all the independent source need to be 0. For current is open, for voltage source it is grounded, right? So what is the relationship between them? Here I say that RF is very large. So what is the potential here? When RF is very large. But what, I mean, let's say you don't know the equation. What is the relationship between V out and VT? Due to what amplifier? Approximately 1. It's a source follower. Yeah, so this is 1. Done. The most important thing is it's positive, right? And then RF is very large. What I want to know is what is the voltage at this point. I mean, what is the current? Sorry, the current going into here. Yeah, what is the current that goes into here? Then again, we go through the trick because of time. I just tell you, you're looking up is 1 over GM1, right? And then this is RF. Okay, and then V 0, right? So what I'm doing is this route. From V out to RF to here, and looking up is 1 over GM1. right? And this is RF. So what is the current that goes into the feedback network in this case? What is K? Is approximately 1 over RF. Yeah, because this current, V or 0 minus V out divided by RF plus 1 over GM equals to I out. This is I out. Is that okay? Yeah, but then GM is small, so I remove it. That's why I out divided by V out is negative 1 over RF, right? We have done that in another class already. Right? Just go back to take a look. Right? So with this, then I have this I, but then the I is going to flow through the RD, right? So the gain is going to be negative RD because it's going down, right? So the loop gain is like negative RD times negative 1 over negative RF, then times 1. So it's larger than 0, so it's positive. So that's why it's a positive feedback based on my definition, okay? I will stop here, but if you have any questions, let me know.